Howdy, folks. So, ever since I posted about my new file server, I've had a couple people ask about how I do backups, how I go about backing up my data. And so, I've actually been working on a new script for automating that process to replace a script that I got off GitHub a while back. And anyway, it doesn't really do what I need it to do anymore, and so I decided to write my own, which has a lot more features. And so I'll be talking about that near the end of this video, and there'll be a link to my GitHub in the description if you'd like to check it out. But before we get to that, we've got to go over exactly what I'm actually doing. So, of course, this is my main file server. This has 8 4 terabyte disks in a RAID Z2, and it has another 4 8 terabyte disks in another RAID Z2. And so that makes up my primary storage. Of course, the 4 8 terabyte disks are new. They weren't in this, I think, the last time I showed the server in a video. It's because I ran out of space, of course. That's why I bought this case, is so that I could eventually fill it up with more disks. And I know that there's going to be some people that say, why didn't you do a RAID 10 with 4 disks instead of a RAID Z2? You get the same storage capacity, and you get better speed. And my answer to that is that a mirror, a RAID 10, is actually only N+1 redundant. Yes, you can suffer 2 disk failures, but they have to be the right 2 disks. If it's the wrong 2 disks, you lose everything. So a RAID Z2 is a proper N+2 redundant thing, and I would have preferred 5 disks, but they're quite expensive, so I didn't need any more than 16 terabytes at the moment, so that's what I put in. I can always tear this apart and rebuild it if I have to. And so the first sort of, I want to clearly note that RAID is not a backup, but for a reliable storage system, you have to have some form of RAID to protect you against, instantaneous disk failure and silent data corruption. You really need that to have something that's truly reliable. It's not a backup, but I think it's the first level of defense, and so any good system should have some sort of RAID implementation. So, of course, I use ZFS. This is a Debian system. It's still Debian Jessie. I have not upgraded to Stretch yet. I'm going to pretty much have to do a reinstall for that. I've tried to do the whole Jessie to Stretch upgrade procedure on another box. It didn't go so well, so I think I'd have to reinstall it. I use Stretch in other places, but my infrastructure is not up to date with that yet, and there's no big rush to do it. I run my own kernels. I think I've mentioned this before. I build all my own kernels and my own ZFS modules, so I'm currently running Linux 4.12 with ZFS 0.7.1, so it's the new 0.7 release. And aside from some strange task hang issues I've had, it's been okay so far. Of course, I've upgraded all the pools, so I can't go back now. There's no downgrading, so I'm pretty much stuck with it, but no major blocking issues with that so far, and I've pushed it pretty hard. I've only managed to get some task hangs when I push it really hard, but they resolve themselves, so there's no serious issues. So this is, of course, where sort of the main data store is. But of course, I have to back up the data that's on this somewhere else. And for that, I have Darwin. This is my my backup file server. Now this, last time you would have seen it, would have been in a different case. And that's because this hardware, this case, and all of the hardware inside is actually from my the file server I had previously before I got the Supermicro rack mount. So this, basically, I've just taken the disks out of my old backup server, put them in here with all the same hardware, just because I like this hardware better. It's a little bit nicer. It doesn't have a proper RAID card in here at the moment, but I have one, so I'll put it in whenever I get some time. Right now, it's just got some cheap stuff in there, but that will be rectified. And so this only has the 8 4 terabyte disks in it, because I haven't yet purchased the 4 8 terabyte disks to make the capacity match. But I'm not totally out of space yet, and so I'm just going to wait until maybe the drives go on sale and I have some more money, because it's like $2,000 for those 4 disks. It's kind of ridiculous. Drives are a lot more expensive in Canada than they are in the US, even when you account for exchange. It's just kind of ridiculous. So anyway, so this is, so as you can see, it's off, and it sits off most of the time. Again, I think I've gone over this before. Some of this stuff is all recap, but basically I have a script, which I'll mention, which powers this thing up, uses Wake on LAN, and then it does a backup. It does an incremental send of all of the data sets that I've tagged that I want backed up, and it backs them up to this. and it manages snapshot deletion and everything like that, and then it powers the server back down. So this thing's only really on for 10 to 15 minutes per day, maybe a bit longer if there's more data, because this thing only has a 1 gigabit Ethernet connection to the other server. There's no InfiniBand to this box, and as far as I'm concerned, it's not really worth it for me to invest in another InfiniBand card and the cables and everything, because I'd have to get quite a long optical cable, and it's like I don't care how long the backups take; it's not a big deal. So this is my second. This is my first, I should say, real backup, and it's automated. So theoretically, if something horrible were to happen, software-wise on my main server, which was to destroy data, when the automated backup would run, it would replicate that to this. And so you do have the possibility that something horrible that doesn't get caught fast enough could propagate to this box and also wipe out this data. And you've also got the fact that because this thing is, it's powered up, technically, right? There is mains power to this board at all times. If there was to be some horrible power event that none of my UPSs, this is on a UPS, but if somehow all the surge protection failed and it fried all of the boxes at the same time, I could theoretically lose the data that way. And so you really need an offline backup. And when I say offline, I mean there needs to be something that is a physical air gap, a physical, it's a disconnect from anything. Basically, it has to be done manually, that kind of a backup, so that there's no automated process or electrical process that could destroy both the primary and the backup. And so for that, I have another machine. And that machine is Lovelace, which is this box here. And this one's in my closet, and as you can see, it has no power. It's not plugged into anything. And I physically have to take this box out and connect it up and manually run a backup on this box. And so this one is in Darwin's old case with Darwin's old board, so I've kind of shifted all of my servers kind of down one notch. As I got the new one, it kind of pushed everything back a little bit, so that's why all the hardware looks a little different. And this one uses the old disks way back when I originally built the first implementation of my main file server. It was actually all 1 terabyte disks, and so this box, as you can see, is all full of 1 terabyte disks in a RAID Z. Actually, not in a RAID at all. Actually, these are all independent Z pools, and so I can get more capacity out of it that way. And that way, if one of these disks fails, I lose what's on it, but I still can recover all of the data on the rest of them. And originally, these were just loose disks in a box. And I thought when the hardware came available, I took this is a Dell PERC card. It's a nice HBA, but it doesn't support disks over 2 terabytes. But since all these are 1 terabyte, I've used that just to connect all of the disks. And that way I can do a much faster and easier backup to all of the drives, even though they're separate pools. And I could do them one at a time, but it's too slow that way. And to sort of squeeze more out of this, I've actually got, I think you'll notice there is indeed a PATA IDE ribbon cable, and that's the boot disk. It's got an 80 gig PATA boot disk. Just shows how much it doesn't really matter what the root file system is. And so this is my offline backup. And so really nothing touches this. And I generally try to get to this 3 to 4 times a year. Of course, it's not going to be anywhere near as up to date, and it's not going to contain all of my data. It's just the most critical data. And again, I should never have to fall back to this, but it's hardware that I have, it's disks that I have, and so I thought I might as well put something on them, and this is where my backup is. Now, this isn't all of my backups. I technically have more. A lot of people are going to ask me about co-location. And I do have a server in another city which has some storage on it that I could use. Nowhere near, not even as much as this, but it does have a few terabytes I could use. The problem is the internet connection I have. My upload is only 10 megabits per second at its best, and so pushing data to it is not very easy. And so I've tried, and it's not really reliable enough for me to do it. I really kind of need to sneaker net data to it by physically putting data on a drive and then moving it, and so it's not really worth it for me. I do also have backups that are not on my premises, so I have a couple loose disks that are in sort of friends and family's houses, and those are kind of like lifeboat drives, is what I call them. In a situation that horrible things happen, like my entire house burns down and everything is gone, I have those, which are again a smaller but more important subset of even what's on this disk. And it's sort of one of those things that as you move down the chain of horrible things have happened and I need to use the further and further removed backups, they get smaller and more out of date, but it's all a cost thing, right? I can't afford to have 4 or 5 times the amount of storage I need. That's just absolutely absurd. It would be tens of thousands of dollars. It's just not worth it. I value my data, but I don't value it enough to go bankrupt for it. You know what I mean? That's kind of the way I see it. So now I want to move on to automation, and I'll just mention some of the tools that I use. The first one, which I wrote quite a while ago, is called Offline ZFS Backup, and this is available. I've mirrored this onto GitHub. I don't use GitHub personally. I have my own Git server, but I do mirror a couple things to GitHub just because everybody looks for stuff on GitHub. And so basically it's a very simple, very small bash script, and all it does is it just basically sends some wake on LAN packets to a server, and it executes some other script. So this doesn't actually do any backup at all. It simply manages an offline server, or sort of a semi-online server. And I just do this for purely power consumption reasons. No other reason other than that. I just don't want that server running all the time. So this can be tied to really any backup script, even something that you write yourself if you wish. But I have my own backup script, and that is, I've just called it ZFS Backup Manager. And again, I've mirrored this one onto GitHub as well. And so in the repo, you get 2 files, sort of the script and a test. So there is an automated test infrastructure that I built for this. It's not super great. It's kind of like a mini unit test script, and it's got, I think, 35 different tests that it runs through. And I've done that more so that when I make a change to the script, I can validate that I didn't break anything. I just read through the output and validate that everything still works properly. And that gives me a bit of peace of mind because, of course, I have had situations where backup scripts can go wrong and they can ultimately end up destroying the backup, and you've got to rebuild it. And that's, of course, not really good. So I like to have some confidence in the changes that I make. And so basically this is, again, it's all bash, and it allows you to do a couple things. So basically you tag the data sets that you want with custom properties, and you specify what kind of backup mode you want and where you want it to go, and how you want it backed up. So it supports local pipes, so if you want to back up to the same box, you can do that. It also supports SSH, so if you want to do encrypted transfers over the internet or something. And it also supports mbuffer. And mbuffer is a great little program which basically packs data into TCP, and it's got little, you can basically specify a buffer on both the sending and receiving side, and it sort of links the pipes together with TCP, and it's very fast. It's not encrypted, but it's incredibly fast. And of course, SSH, you're going to be limited usually not by the network, but by the CPU in your 2 machines. So mbuffer, if you're on a LAN, I suggest you use that mode. It is the default. And you can actually you can saturate your disks basically if you've got a fast enough, like a 10 gig or InfiniBand or something. You can saturate the network with that, so you can get a lot faster backups with that mode. And basically, yeah, it just automatically scans through everything, does your backups, and that's about it. So I wrote this last week. As you can see, I just put it up on GitHub, and so it is ready. If you'd like to use it, I'll accept pull requests if you've got some meaningful changes. One thing that I should mention is root file system backup. So I recently migrated all of my servers to basically root ZFS. So they also used to all be ext4. Now none of them are ext4 anymore. And of course, as a result of that, I can now use ZFS send receive to back up my root file systems for all of my servers. And so that's what I do. And this script has a special mode for root file system backup. And so it'll basically, you can sort of nest root file systems in sort of little namespaces, and that way you can do proper backups with the ZFS-F option, like receive-F option, and not destroy stuff on your pool that's unrelated. And you can also back up stuff that has the same name, which is useful. And one other thing it does is it sets the mount point in flight as the receive is happening to none, so that if you have multiple, of course, if you have multiple root file systems in your pool and you try to mount them all to the same mount point, of course, horrible things happen. So there's handling for that automatically, and you can also write custom properties. Basically, you can write custom ZFS receive options and stick them in the properties, and it will run those if you've got special, really weird things that go on. Because that's kind of what I'm doing. I'm backing up all of my server's root file systems to my main file server, but I'm not backing them up to my backup file server. Basically, I don't want to replicate all of my data everywhere. I'd prefer to have one backup destination for everything and not two. Simply because if something horrible goes wrong, I don't want failures to propagate between all of my systems and somehow erase backups on everything. It's hard to explain why I want to do this, but I have had things happen in the past, and you start to get kind of weird logistical issues where you're backing up data from box A to box B, and then box B is backing that up to box C, and you've got to have different parameters for each backup. And so you have to have some sort of way to control that, and it's not super easy. So I decided to just have one backup for each thing, and I'm good with that. I mean, the likelihood of losing one of those two file servers is incredibly low to begin with, so I'm not worried. And of course, none of my servers had ZFS root up until about a month ago anyway. So I clearly it wasn't that big of a deal for me. Lastly, I'll tack this on, I guess. It's kind of storage related. This is my application server, and this unit used to have two ext4 SSDs in here. One of them had some VDIs, had some virtual machine images on it. The other one was root file system, and so I've now that HP SSD that I bought, that I did that sort of review down thing on, I put that in here, and this has now a RAID Z1 of three 120 gig SSDs, and so this backs up, of course, now, but it is its own RAID Z1, so it's relatively safe, and that HP SSD is seriously a problem, actually. Basically, one of the nice things in the new version of ZFS 0.7 is there are histograms that you can get for latency, I/O latency per disk, and it's very detailed. You can actually get really interesting like tab-separated value outputs for each disk, and you could actually write a script or put it into Excel or Calc or something and actually do graphs and everything. You can get a lot of data out of it. And it's designed to allow you to inspect the timings and see if there's a disk that's slower than the rest, and it allows you to find failures quicker and stuff. And that disk is horrendously slow. It's bottlenecking the whole system as far as writes go. And so it's okay at this point. I mean, there's no real super high throughput I/O on this box, but it is definitely way slower than any of the other SSDs that are in there. Now, I had a couple people mention, did I run trim on that SSD before I ran those benchmarks? And the answer is no, I did not. And yes, I know if I ran trim, then the write speed would probably be close to what they specify on the package. But the reason why I didn't run trim is because of course, ZFS doesn't have trim support. ZFS on Linux does not have trim, I forget what they call it. BSD has some form of a trim implementation, but the Linux port does not have it. There is code available, but it is not merged into the mainline yet, so I don't know when that feature is going to happen. They've merged it in encryption already, but they haven't merged in trim. So, of course, trim is super serious. You screw that up and you erase data. So, of course, I'd rather wait for it to be stable. But just because ZFS doesn't have trim support trimming the disk and then benching it would not really show me real world performance, because eventually the disk would get full and the performance would tank to that anyway. So I just wanted to see what the performance of that SSD was like in my use case. And a lot of people said I harped on that SSD, and I don't like HP. If anyone who's bought in their products recently will know they're not really the company they used to be. And yeah, it's a fine SSD, but just know that under perfect circumstances you will get the spec, but under my circumstances, which is what I was testing it under, you don't get those. So it's not that I'm just hating on them for no reason. I'm just putting that out there, that it really did not perform as well as I thought it would. It really does need trim to be sort of usable at all. It's otherwise it might just as well be like an SD card. So anyway, that's just an update on what happened with that. So I hope that covers all the questions people had as to what's going on with my backup situation. That's sort of how I've been doing things for quite a while, and how I plan to keep doing things. I think it'll work out pretty well. And a lot of people, like I said, people have asked for a status update about this. Not really much I can update you on. One question you may have is, why are these disks all over here and not over here? And it's because these 7200 RPM 8 terabyte disks are they produce so much heat that when I put them all here all together, they were sitting way too hot. They were like 56 degrees each, and whereas the old disks are like 37. So I actually spaced them out over here where there's no adjacent disk above or below them, and as a result, they stay much, much cooler. They're like 43 degrees. So that's much better. So that's why they're all over here. It's just because I have the room, I might as well spread them out. I was thinking actually, because I have 12 disks, I could actually checkerboard this, where I could have one skip one have skip one. I could do that across the entire board, and it would look kind of cool, but I'm really not interested in taking them all apart and then unscrewing each disk and moving them into different caddies, because these stickers, I've tried to just take the stickers off and move them around. It really doesn't work too well. The glue is not friendly to removing, so and I like having them properly numbered 1 through 24. So that's why those are spread out, if anyone wonders, because I originally had them all together and it didn't work out too well. That's it for today. So as always, thanks for watching.